Hi guys, and welcome to our next video. This video is practical as well, and it's all about process, threads, and actually the permissions. We're gonna cover all that thing, and for now about the process and threads, you don't need to actually go in depth, in detail, because this is a really huge and really massive team. There are really a lot of information there, but I want to pay a close attention to permission one because this is for now a really actually important topic. So first let's cover the process. We already know what is a PID or process ID, but what is actually a process? A process is basically whenever a program is running, no matter in Windows or Linux, they are working quite the same. The principle is quite the same. Whenever the program is running or is run, the operational system is creating a process that is actually constantly interacting with the memory and the CPU of that machine so that the program can run. The process just stays there and are just getting resources and is actually doing its work. And there are tools to actually check how much process we are running actually, like a top or PS, and that tools are showing us much information. So the main idea of the process is that is just a program. Every program is a process, and therefore the process is just getting resources and doing its own thing. That's what it does, nothing more. Just getting resources and doing its own thing. That's what was it programmed to do. So what's a thread? A thread is basically is something kind of like a process, but it's not that heavy. It's lighter, and it can start from process. So the process can create threads, and threads are just going there and connecting with some kind of memory, for example, or devices. They are just making some kind of connections, and they are start obtaining more resources, and the stuff goes really high and huge. We're gonna see all that stuff in future. So for now, just remember that thread can be started from a process. So now let's take also a look at top command. We have like many programs here, and as you can see, even the console has its own process with the current PID, as you can see here. The console. So for example, now if you actually kill the console, like go for kill 5006, here is the PID. So we're gonna actually close our console because it's a process and it's actually self-destructing by saying kill that process. So go top again, and let's see what other information we have. For example, we have the PID, we have the root. There we have some percentage of CPU and RAM, and which is the most important for us. So our console, for example, is getting 1% CPU. Here we are 4% CPU, and that percentage of RAM. So here is the graph of actually what process, how much RAM it's actually consuming and it's actually using. And this is really important in order to see how much we have left, and if we don't have any, to see where the RAM goes. This is really important and actually really useful. And here on the top we have even the buff and the cache size of the memory, so it's great. So now this is how you actually manage process, how you kill process, and you need to know that every program, every software you run is actually starting process. For example, let's open your terminal and go for like get it. You're gonna see get it now here. Yeah, there it is, get it. So as you can see, every program we run is actually starting a process. Every program. But for example, like from the terminal here, where our console has already a process to our machine, from here we can start threads and we can start sub-processes. And for example, we can go like get it again and get it again. So now we have two instances of get it running that specific PID, on that specific PID. So now our terminal window has actually created two separated processes. They are now quite independent because if we exit that, they're gonna still work, and we have to get it instances. So close without saving. But if we actually create getIt without background, so if you run it just as getIt, we are creating not a process but a sub-process, a child process. So this child process is actually child to the console, and here if you actually kill the console, like like Q5950, everything is going to disappear, because we actually created a sub-process of getIt for our console. So when the parent process is dead, the child process is actually dead again. And that's why sometimes there are zombie processes, because when the parent process ends, the child somehow still lives and it becomes zombie. So it's actually getting resources, but it's not usable. So this is all about process for now you would need. And now let's further move on to permissions themselves. So let's open a terminal and actually do a simple ls command. And now we see all the available files out there and their names. But now if we go for ls-la, now we're gonna see all the available files, including the hidden ones and their permissions. So now what does it mean, the hidden file? A hidden file means a file with a point before its name. So for example, if I create a file like touch my file, and then rename that file, and we can rename that file by moving that file, so mv for move and cp for copy. So we can just copy my file 1, we have now 2 files, but we can move file 1 to actually, for example, to desktop. Now we're gonna see there is my file, so cd desktop, and with move we can actually rename that file, so move my file into .my file. Now the file is going to disappear because we hide that file by specifying the point before its name. It's no matter if the file has some extensions, for example touch. So if you go move, move, it's going to do the same work. So now if we go ls, we're not gonna see the files, but if we go ls-a, we're gonna see all, a for all. So now we can go for like remove my file, remove, we have one file, another file, so remove file 1.mp3, so clear that, lsa again, see if we have not something needed. Okay, so now it's good, so clear cd, and now go for ls-l, that means to show the permissions about that specific directory. And if you go ls-la, we're going to show all the available files with all the permissions on them. So just click enter, and now the first thing we see are the permission table. So the next thing we see is actually the root, the owners of the file, and therefore the size and the date. So now we can actually pay close attention to the permission table here. So the first thing we have to inspect is that we have the D here. The D means directory, so that file is directory, and for example that file is not, that file is directory again, and they are often colored as different color as you actually specify the color in your console emulator. So now D means directory, and therefore we have 3 types of extensions. We have read, write, execute, read, write, execute, read, write, execute. We have 3 pairs of that. For example, to be more clear and simple to understand, just see desktop and create new file, touch my file, and then with the command chmod we can specify the permissions for the file. So chmod 777, and then go for my file. Now if we go for ls-l, we see that my file has no D, so it means that it's not a directory, and it has read, write, execute, read, write, execute, read, write, execute. This is the permission of that file. So now I'm going to explain every single one of them, what do they do. So we have 3 pairs of read, write, and execute permissions. So now let's just break down what do they mean. We have 3 actually pairs of read, write, and execute, and we can explain what do they stand for? The first one, read, write, execute, is just for the admin, for the high privileged one, so they can read, write, and execute that file. Therefore, we have the another read, write, execute, and those are for the groups. So you can create different groups, different kind of groups, and give you parameters of the groups themselves. So, for example, if you're running a server with many people, for example, 100 people, you don't need to specify permissions for every single one of them. You just need to create a group, and everyone in that group is going to have the same permission. This is the whole point, to make the job of sysadmins easy. And the third one is anyone else. So any authenticated user, any user connects to our server, any user at all who can visit that file, who can actually see that file, can do all the things that he is allowed in that permissions, either to read, write, or execute that file. In most cases, those are the users that are not in any single group, and for example, those users are most likely to have any kind of permission. You need to be really strict and really actually careful about what permission you give and about what permission you have, because Linux, a lot of problems in Linux depends on permissions. No matter installing the web server, installing any kind of stuff, installing software, if you don't have the permission, Linux is not going to allow you to install anything. This is how Linux is made, and the biggest problem of Linux hacking is to actually get over those permissions, to break through them, or to actually escalate our privileges. For example, when we hack to a Linux server, the chance we hack to a root user are very small, and therefore we can most likely be hacked into some kind of regular user with some kind of group permissions, and therefore in actually to build our way into the root one, we need to actually use exploits and do some kind of privilege escalation attacks. So to do more things, to be more like to have more control. Because as a normal users or the users in some kind of group, you have a little control, but not that much. For example, you can create your own files and execute your own files, but if an administrator create the file and don't say you can execute it, there's really a pain of executing that file. So the Linux biggest problem are permission and firewalls, and we're gonna see firewall in the future how they work. But for now, just bear with me that the first one is directory, then we have three pairs of read, write, execute. The first one is for the admin, for the high privileged ones, then we have for the groups, and then we have for everyone else who visit that and actually can see and access that file or directory. And the permission is the key of successful actually Linux server setup. If you set up your permission carefully and actually strictly and right, the chance of getting hacked are less likely to happen, because the biggest problem, as I said, on hacking Linux server are exactly the permissions. So we need to get actually into the root user account. If we get to that root user, it's game over, we won, because as we said before, in Linux, when you are root, you can do completely everything, and you can completely own the system and do whatever you can. So whenever you become root on the machine, on the server, on the attacker, on the victim's machine, sorry, the game is over. So this is our goal, to become root. And becoming root is done by escalating and bypassing those type of privileges and permissions. So we need to actually bypass that permissions and to execute things that we are not supposed to. And this is really hard and actually good topic and interesting, and you're gonna see all that in future videos. And for now, let's see how to actually change the owner of the file and change the permissions. So to change the owner, use the command chown. Yeah, and to change the permission, specify chmod. And we can go for chmod plus hex, which means executable. So now, how does the Linux permissions are defined after the chmod? The 4 stands for read, the 1 stands for write, and actually 2 stands for actually execute. So that means for read, 1 write, and actually 2 for execute. So that means 7. And when we go for chmod 777, we have different types of actually options, like chmod 777 about my file. This is gonna change the read-write execute permission for owner, group, and users, everyone else, is gonna set to be able to actually modify everything. So the 777 is the biggest permission weak, and we can see that the users or the overall users about that file can do completely anything. So remember that 4 means read, 1 means write, and actually 2 means execute. So we have 3 pairs of numbers, and we can go like chmod 777, and then we go for 1711, sorry, my file. Now if we go and actually save my file, we see that only the high privileged account can actually do whatever he wants with that file, and the other two, the groups and the actual users who connect to that server, can only execute that file. And if you go for the 0 in chmod, this means that it's not completely usable. So whenever we set a 0, so that means for the third pair, no one who connects to our server, to our machine, can ever do something with that file. He cannot read, he cannot write, he cannot execute that file, and that's it. So Linux is really simple. It's based on really simple stuff, and really simple but many. And when combined, they are doing their job correctly. And the permission is the best example for that. When you see the permission themselves are actually some basic stuff, they are just who can read, who can write, and who can actually execute. But when set up correctly, we're gonna have a lot of troubles bypassing that permissions and actually escalating our privileges to the way of the root. Because when we become root, the game is over. And you're gonna see that in the Linux, there are many more stuff like that. For example, the networking commands are very simple, but are many, and you need to learn a lot of them. And many tools built on Linux are built that way, and many more stuff. For example, the Nmap. The Nmap is just a simple tool, but when you start digging into the options, you're gonna see it's not that simple. And imagine you have a server with a lot of files, a lot of servers there, a lot of services, and you need to set up the proper permissions. So it's not that easy, you know. And this is our worst enemy about Linux, the permissions and the actual firewall. So thank you guys for watching. I hope this was interesting for you, and I'm gonna see you in the next video.